All right, today we can talk about Lewis structure. What is Lewis structure? It's the structure of the molecule. For example, if I write O, H, and H, that's structure of the molecule, but Lewis structure will look like, if we go into details, of course, will look like this. Hydrogen, hydrogen, and these two form the bond. Now, how do we actually get there? How do we know how many points do we need to put, how many bonds are formed, and so on? Let me give you a different example. Let's talk about CO2. Now, we have to look at the amount of electrons on the last orbital and put those dots around each element. I'm going to put C, O on one side, and O on the other side because we have two O's. Now, how to know how many electrons are on the last electronic shell? Well, let's go back to the periodic table. Again, all the answers are in the periodic table. Let's see. Carbon there are different ways to look at it. So I'm looking at the carbon right now. Different ways. So for example, you can look at the group that carbon is in, and it's group 14. But actually, in the periodic table, we cover this one. What's this group? Group number 4. Therefore, there are 4 electrons on the last orbital. However, what else you can do? I don't know the type of the periodic table that your teacher gave you, but some of them have this. This is called electronic configuration, which you don't need to know right now. But you can see that these exponents have 2 and 2, right? So 2 plus 2 will be 4. But of course, it's easier just to look at the group. Unfortunately, it doesn't work all the time. I would say 95%. And again, as I said, those 5%, they are a bit more complicated, so you will be taught it separately. So we know that carbon has 4 electrons. Let's go back to the example. Since it has 4 electrons, I'm going to put dots. I know that there are 4 electrons. I'm going to put it here. Now, I'm going to put it clockwise. 1 on the top, 1 on the side, 1 over here, 1 over here. How many did I already use? 4. Done, right? So 4 are gone now. I distributed them. Now let's go check the oxygen. Oxygen is in the group 16. Again, I'm covering 1. And here we go, 6 electrons. Sure, let's put them. Now, how to put 6 electrons if I just showed you how to put 4? Because you can go, again, the same way, around, 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 but then how many do you have left? 2. So in order to put 2, you cannot put them around just like this, like some sort of flower. No. You have to do pairs. Electrons like to pair. So I call them lonely electrons, the ones that they don't have pair and they're trying to get pair. And that's the main concept of Lewis structure, is that electrons are trying to pair with other electrons. So we have 2 more to put. I'm going to put them over here. And for example, over here. Do I have 6 dots around oxygen? Yes, I do. So that's it. Now let's do another one with the oxygen. Same oxygen. I put 2 dots, and again, I'm going to put 2 around. 6, 6. Now, how many does oxygen have available? Lonely electrons. Lonely, or a lone electron, is how many do we have? 2 on each oxygen. How many available electrons does carbon have? 4. Well, how convenient it is that now we can use those 2 lone electrons to pair them with 4 electrons of carbon. Look what's happening. These are paired. This is paired. This is paired. And this is paired. That's it. So now, if I write it out correctly, I will get C, double bond O, double bond O. And don't forget about electrons that are left, which are the paired electrons. And that's the Lewis structure. Just a little bit more details here. When you have double bond, not always, right? Because, for example, water doesn't have double bond, which we're going to cover in a second. This bond is called sigma, and this bond is called pi. You probably know pi, right? Pi is equal to 3.14, but it's related to math. When we talk about chemistry, it's just the name of the bond. It's not related to the number. I'm going to talk about water now. Water has formula H2O. So again, I'm going to put element that is 1 in the middle. Oxygen. Hydrogen. Hydrogen. Oxygen, we remember from the last example, we have 6. Now, hydrogen, if you look at the periodic table, in group number 1. So it's literally going to be 1 dot for the hydrogen. 1 and 1. Well, how convenient it is that oxygen provides 2. So each of the hydrogens can have 1. So now we have single bond, which is sigma, and that's your loose structure. Don't forget to put electrons for the oxygen. That could be considered as a mistake if you don't. Now the length. Single bond is longer than double bond and is longer than triple bond. So if we consider CO double bond O and OH, the length of water bond, not the water itself, of course, but bond between oxygen and hydrogen is longer than bond between C and O because it's double bond. Of course, if we had triple bond, that would be even shorter. Example of triple bond I will go over as well. It's NH3. And not because we have 3 over here. I mean, this is the consequence of that. But actually, it's also self-explanatory. N, and we have H's. So allow me to put them around N. Now let's go back and look at the nitrogen. Which group it is in? 15. We cover 1, group 5. Let's go back and put 5 electrons around nitrogen. How many did I put? 4. How many left? 1. I'm putting 1 over here. Hydrogen has 1, 1, 1. Now, combine these 2 electrons, these 2 and these 2. Now, we can leave it this way, it's loose structure, but you also know that now, with N and H, you have not a triple bond, but you have H and H. So if we do this as a sigma, this is going to be short. But when I said triple bond, I meant, of course, triple bond is something like this. But triple bond, in this case, will be the triple bond, 3 same bonds. That's what I meant. So that's it.